Good morning, students. So today we continue looking at the various types of chemical reactions. And the first one we're going to look at is ionic precipitation reactions. So before we get into our work, let's bow our heads for a word of prayer. Our loving Father in heaven, we're thankful for life and even for the opportunity to continue to prepare these students for their exam. I pray, dear Lord, that you will be with our session. May it be fruitful, and moreover, let these children be able to understand the content so that they can apply it in their exam and gain passes. Thank you so much for what you're doing for them. Continue to bless their homes too and provide for their other needs. For this is my humble prayer in Jesus' name. Amen. All right. Ionic precipitation reactions. Now you might be wondering, what is a precipitate? Anyone here knows what's a precipitate? Have you heard of the word precipitate before, Elisa?
Yes, I have.
So what exactly is it?
Precipitate is the forming of a solid when you mix acids and base, I think, together or something.
Yes, basically when you have a reaction occurring between two solutions and you have an insoluble solid, what we call the precipitate being formed, right? Now, when you hear the term ionic precipitation, you can also think of double displacement reactions. Now, last week you did single displacement reactions, right? So basically you can say you have two couples here, A and X and B and Y, and they exchange partners. So this is why it says double displacement. So they're displacing each other. So A and Y combine and X and B combine. So you have two other products being formed. One of which is called precipitate, which is the insoluble precipitate. And you can see them easily. Right? I normally do a lab on this at school. When my students come to it, we'll get it soon enough. Yes, to form precipitates from two solutions. So during a reaction, you have two compounds in solution. They exchange ions to form an insoluble precipitate and another soluble compound. Right? So to get the precipitate, we can filter the precipitate out, set up a filtration apparatus, and then we filter and wash the precipitate and allow it to dry on the filter paper to obtain it. It's a very simple reaction. In this example, we have lead nitrate and sodium chloride combining to give you lead chloride, which is the precipitate. Notice you see the solid symbol there. That's the precipitate. And sodium nitrate, which is also in solution. All right. Any questions on that one?
No.
All right. So as you go along, you'll get to see more reactions and be able to classify them within the different categories. Now we come to oxidation reduction reactions. All right. Now there's a whole entire chapter on oxidation reduction. So I don't want to get into the meat of this, right? And you have different definitions for oxidation and reduction. When you come to that, we'll come to that. So take it as it is, an oxidation or reduction reaction, we call it a redox reaction when both are occurring. When one reactant is oxidized and the other is reduced. Now, these reactions are also called what? Redox reactions, when you have both happening, oxidation and reduction. Now, there's another chapter entirely with this. I'm going to leave it for then. This is just a brief introduction. Right? So the next one we have is neutralization reactions. Now, you might have done some work with acids and bases. So when a base and acid reacts, you have the production of a salt and water. So in our example, we have potassium hydroxide reacting with sulfuric acid to give potassium sulfate and water. Now, all of the salts that are made from sulfuric acid are called sulfates. If we had if we had what is really going on with my tongue tying this morning? Hydrochloric acid. Do you know what would be their classification? Hydrochloric acid. What type of salt would you get, Elisa? You have a base reacting with an hydrochloric acid. What type of salt would be made? You understand the question?
I somewhat understand, but
Don't know
I
the
don't
answer. Don't be afraid to say that you don't know the answer.
I don't know the answer.
All right. So if you have a base reacting with hydrochloric acid, you have chloride salts forming, right? Yes. So normally that's how they are categorized. All right. So neutralization reactions. So simple ones, acid and a base or alkali as we know them react to form salt and water. So once you see the products of a salt and water only, it's most likely you have a neutralization reaction occurring. Then we have reversible reactions. Notice the fancy symbol with the arrows, right? In the middle there. Can you see my course?
Yep.
Yes, it's right there. So during a reversible reaction, the direction of the chemical change can be easily reversed. So basically what happens is that you have the reactants combining and making products. And you also have the products returning to the reactants, right? So that is why we have this fancy symbol here in the middle. So at no point would you find all the reactants being converted to products or all the products being converted to reactants, right? So yes, you don't have all your reactants being converted to products, nor the products being converted to reactants. Some of them, to some degree, you have both reactants and products being formed in this reaction. All right, so in our example, we have ammonium chloride being heated. It decomposes into ammonia gas and hydrogen chloride gas, right? Now, if they cool the gases that are made or mix them at room temperature, they react to form again the ammonium chloride. That is what our the example is telling us here. So if you cool the gases, or mix them at room temperature, they react to form what they came from the ammonium chloride, right? So the reaction is therefore called a reversible reaction. And normally when you see that symbol in the two fancy arrows, we know that this symbol tells us that the reaction is a reversible reaction. You've seen these arrows before, Elisa?
Yes.
Good. So in many of the reversible reactions, the mixture of the reactants and products, it contains a mixture of reactants and products because it proceeds in both directions. We have the forward direction, which is where the reactants go and they become products. And we have the backward reaction where the products return to form reactants. So note that most reactions can only proceed in one direction and they are not reversible, right? All right. So let's see. We have some questions here. Let's see if we can do a little bit of answering. Classify each of the following reactions. Let's see. Now, A says the reaction between calcium and hydrochloric acid to form calcium chloride and hydrogen. All right. So you said you didn't get to look at the previous notes on the other other reactions. All right, in the first one, the first example, we have a metal reacting with an acid, right? Trying to get to I went too far up. Yeah. All right, so now in that reaction, we have a metal displacing the hydrogen from an acid. So if you were to write this, can you write a chemical equation for this reaction between calcium and hydrochloric acid to form calcium chloride and hydrogen, Elisa?
Yes.
All right, please do so for me and inbox me your answer. I'll give you some time. Calcium and hydrochloric acid to form, put in your state symbols also, right? To form calcium chloride and hydrogen and ensure your equation is balanced. I'll give you 5 minutes. Let's give you 5 minutes.
Okay.
I sent you a list of the anions and cations, so you'll be able to write your chemical formulate correctly. Are you getting through, Elisa?
I think I'm finished, but
Send me a pic of your stuff on WhatsApp of your equation so I can see what you did.
okay.
Man, my neighbors are noisy with their work. Mhm. All right, so first of all, this is a normal reaction. You have a reversible reaction symbol there. That should not be there. Calcium. Calcium, when you're writing it as a metal, it's just Ca and solid in brackets. It's not an ion. You have Ca2 plus there. Take out that 2 plus and in brackets put solid. Now you have the formula for HCl, correct? Which is hydrochloric acid. You put AQ in brackets. Take out this the reversible reaction arrow. Just put a normal arrow. Calcium chloride. All right, now when you're doing your chemical formula, always think of the ions that combine. So first of all, we're gonna do the formula for calcium chloride, right? This is calcium, Ca2 plus, and chlorine is, can you remember the chlorine ion? Cl minus. So this is what I normally do with my students. We represent the charges as hooks. So for calcium, you have 2 positive hooks. And for chlorine, the chloride ion, we have 1 negative hook that bonds with one of the positive hooks. Now note, this hook is without a partner. So we definitely have to add another chloride ion to balance it out. So in a formula, when you're writing your compound, the formula for your compound, the positive charges and the negative charges have to cancel each other out. They must be equal. So according to what we have here, this is 1 atom of calcium. And how many chloride ions do you see here? Atoms of chlorine. 1, 2, right? So the formula is CaCl2. So this is how you figure out how to write the chemical formula or formulae. Yes, for compounds. So where you have CaCl, please put in the 2 at the bottom. And the gases are diatomic, meaning it's 2 gases here. These gases here. So it's going to be H2. Right? And you're putting a state symbol. So for calcium chloride, this guy is aqueous, it's very soluble. A, so you put AQ in bracket. What happened there? Don't know what happened there. Anyhow, the color was what? Yo, what's going on with my color? So it's AQ, right? Can you get me a Q quick? And gases we know we represent as G. Gaseous state. All right, please send me back a pic with all your corrections when you make them, so I ensure that you have the correct thing there. Right, so you have to take out that 2+ by calcium, put in solid state, HCl, put in aqueous, AQ in bracket, 1 arrow, normal arrow is not a reversible reaction. At least I don't think, no. Calcium is CaCl2, AQ, plus H2, gas symbol. Please send me back the correction. Make your corrections and send it back to me. Good. So you have the correct balance equation, right? So once again, we're going to look at it here again. Let's look at it. So note that in this reaction, we have calcium, which is a metal, displacing the hydrogen from the acid to form calcium chloride and hydrogen, right? So notice that it's a metal displacing the hydrogen from the acid, and that gives us, which one? I'm going to update now to show you. It's called a single displacement reaction. So the metal is going to displace the hydrogen from an acid or another metal from a compound. In this case, it's a metal displacing the hydrogen from the acid. So this first one, and please write next to this equation that it's a single displacement reaction. That's that one there. So this is single displacement. So 1A is a single displacement reaction. Let me take out all these guys, these writings. Come on, guys. Clear them off. Let's look at B now. So B now is iron reacting with oxygen to produce iron 3 oxide. Now here we have 2 reactants combining to make a product, one product. So if you remember, oh yeah, you said you didn't get to look out the last video. Nonetheless, this is called a synthesis reaction, right? Synthesis reaction. Let's go up to it. Synthesis. So we have 2 in our example. It's 2 things that are combining to make one. Shh. This darn cat is not my choke. Out. They combine to make a single product, and that's what's happening in our reaction there. All right, so we have, what are the 2 things combining? We have iron and oxygen coming together to make iron 3 oxide. All right, please write an equation for this reaction for me, Elisa, and send me a pic of your answer. We have 7 minutes to go. I think I'm going to stop there at B for today. But what you're going to do for me, you have C, D, E, and F. I want you to write the balanced chemical equations for these guys and tell me which type of reaction is it from the ones that we did thus far. And this is the end of this chapter here. So remember, you have to write out the reaction for B, C, D, E, and F, but you already have the answer for B, which is a synthesis reaction. So you write out the equations for C to F, and then you tell me which type of reaction it is. And I need my homework by 4 o'clock today, so I can check to see if you understood what we dealt with today. Do you understand, Elisa?
Okay.
So you got some practice in writing chemical equations. Please don't be Googling this thing. If you can't remember how to write the chemical formula, go back to the video on the work I did with writing chemical formulae. Look at the ions that I sent to you, that I inboxed to you. And just as I did with the hook method there, ensure that your positive charges are equal with your negative charges, and then you write the formula without any charges. Because the positives and negatives cancel each other out, so the chemical formula is neutral. All right, that's it for today. We only have homework for 4 o'clock, right? Good, so I'll be looking out for you. All right, enjoy your day, dearie. Bye-bye.
Bye.